Today we talked about even and odd functions. These are kinds of symmetry. The algebraic understanding of even and odd says that a function is even if f of minus x is the same as f of x, for every x that makes sense. What that means is that it doesn't matter if I put in a positive or a negative number, the function is going to give me the same thing out. This function is an example of an even function. If I put in a positive or negative number, I get the same thing out. And to prove that, if I plug in minus x everywhere I see x, I notice that minus x squared, that's the same as x squared. Cosine of negative x is the same as cosine of x. Minus x squared is the same as x squared. But this gives me f of x. So if I plug in a minus x, all of those minuses, for one reason or another, go away, and I'm just left with my function. That function looks like this. And it's a complicated function, but if you were graphing it, you could be rest assured that you only had to graph, say, the right half, not the left half, because the left half would just be a mirror image. That whenever I have a local max on one side, I have a local max on the other. Whenever I have a min here, I have a min over there. Now let's talk about odd functions. This is an example of an odd function, and we can see that again by plugging in minus x for x. If I cube a negative number, it's still a negative number, but cosine of minus x is the same as cosine of x. Cosine is an even function. X squared is also an even function. Minus x squared is the same as x squared. So altogether, I get that if I plug in minus x, I just get a negative times what I get if I plug in f of x. So this tells me that the function is odd. And here's what that function looks like. And again, if I were graphing this function, it'd be a pain. This is a difficult function, but I would only have to graph half of it. Wherever I have a minus, it turns into a plus. Whenever I have a max, on the other side, it turns into a min. Whenever I have a max on this side, it turns into a min on the other side. The reason they're called even and odd functions is that even functions, examples of even functions are x squared, x fourth, x to the sixth, x to any even power. And x to any odd power is an odd function.